Hello my dear students, today I will explain you the questions based on binomial distribution. The first question is 10 coins are thrown simultaneously and we have to find the probability of getting at least 7 heads. So in this question 10 coins are thrown simultaneously. That is, we have to given the number of trials is equal to 10. And what we have to find out? We have to find out the probability of getting at least 7 heads. That is the success denoted by getting heads. That is the binomial variate x, we will take number of heads. So this is x and we both written. Now getting heads, that is the probability of success getting head is 1 by 2, and probability of failure, that is getting tail, that will be also 1 by 2. So according to binomial distribution, probability of x is equal to r, that is probability of success given by NCR p raised to the power r q raised to the power n minus r. At least 7 heads probability we have to find out, that is probability of x greater than equal to 7, and probability of x greater than equal to 7 we can write down probability of x is equal to 7 plus probability of x is equal to 8, probability of x is equal to 9 plus probability of x is equal to 10. In this way we can write down. Now we will apply the binomial distribution formula. So this can be written as 10c7 p power r, that is 1 by 2 raised to the power 7, and q raised to the power n minus r, that is 1 by 2 raised to the power 10 minus 7. So total, if we will do, then it is equal to 1 by 2 raised to the power 10. Similarly, here we will write down 10c8. The total sum will be equal to 10, because you will see that power of p, sum of power of p and q will be equal to small n, and here p and q, they both are same. So this will be written as 10c9 1 by 2 raised to the power 10, and in the last we can write down 10c10 1 by 2 raised to the power 10. 1 by 2 raised to the power 10 we will take common, and within the bracket this will be 10c7, 10c8, 10c9 and 10c10. This calculation you can do by the scientific calculator, and using scientific calculator you are getting the answer 0.172. In the second question, if 10% of pens manufactured by a company are defective, find the probability that a box of 12 pens contain exactly 2 defective pen, at least 2 defective pen, and there is no defective pen. So here we have to find the probability of defective pens. So the number one we will write down, that is the random variable x denote defective pen. X denote defective pens. And we will also say that is probability of success is equal to the number of defective pens. A box contains total number of 12 pens, that is the small n value is 12. Probability of success, 10% of pens manufactured by a company are defective, that is the probability of success is 10%, that is 10 upon 100, which is 0.1. That is probability of failure q, we can write down 1 minus 0.1, that is 0.9. Now one by one we will find the probability. The first one we have to find out probability of exactly 2 defective pen. Exactly 2 defective pen, that is x is equal to 2, that is the value of r is equal to 2. So using the binomial distribution we can write down 12c2 probability of success, that is 0.1 raised to the power 2 and 0.9 raised to the power 10, 0.2301. Second, we have to find out probability of at least 2 defective pen. At least 2 defective pen, that is x greater than equal to 2. If we will open probability of x greater than equal to 2, then it will be probability x is equal to 2 plus 3 plus 4 up to 12. So it will be very lengthy calculation. So we can write down probability x greater than equal to 1 minus probability x less than 2. And 1 minus x less than 2, that is x is equal to 0 plus x is equal to 1. Using binomial distribution, we will write down the value. So it will be 1 minus 12C0, 0.1 raised to the power 0, 0.9 raised to the power 12, 12C1, 0.1 raised to the power 1, 0.9 raised to the power 11. Using scientific calculator, then answer will be 0.341. Third one, probability of no defective pen. No defective pen, that is probability of x is equal to 0. And this can be written 12C0, 0.1 raised to the power 0, 0.9 raised to the power 12. And it will be 0.2824. So this is the way how we can find out the probabilities of defective pens. In the third question of binomial distribution, we have to find the parameters of binomial distribution whose mean is 10 and variance is 6. So in this question, firstly, we should know what is meaning the parameters of binomial distribution. So we already studied, that is, if x denote the parameter of binomial distribution, then this is equal to bn comma p. So our target to find the value of small n, that is the number of trials, and small p, that is the probability of success. And what we have to given? We have to given the mean is 10. So the second point, mean of binomial distribution, we know it is x bar, which is equal to n into p, that is equal to 10. Let equation number 1. And the variance is 6. Variance is equal to 6, and we know that the variance of binomial distribution is npq. So npq is equal to 6, equation number 2. We have to find the value of n and p, so we divide equation 2 by 1, so npq. So here we will divide equation 2 by equation 1, that is npq upon np, which will be equal to 6 upon 10. So NP and NP, they both will cancel out, and Q will be equal to 3 by 5. When Q will be equal to 3 by 5, then we know that P can be written as 1 minus Q, that is 2 by 5. So the value of P is equal to 2 by 5. Value of Q is 3 by 5. Since NPQ is equal to 6, then Q can be written as 6 upon N, then N can be written as 6 upon PQ. 6 upon PQ, that is 2 upon 5 and 3 upon 5. That N will be equal to 25. So binomial variate, we have to find the binomial parameter. So it will be equal to 25, comma 2 by 5. So that is binomial variate. In the next question of binomial distribution, we have to given out of 800 families with 4 children each, how many families would be expected to have number 1, 2 boys and 2 girls, number 2, at least 1 boy, number 3, at most 2 girls, and number 4, children of both sex, and assuming that equal probabilities of boys and girls. When equal probabilities of boys and girls, that is, it will be 1 by 2 and 1 by 2. And how many children each family? 4 children, that is the value of n is equal to 4. Now the random variable, so you can see that we have to find the probability of 2 boys, 2 girls, at least 1 boy, or at most 2 girls, and children of both sex. So either we can assume that x denote the number of boys, or we can denote the x denote the number of girls. So here, and you have to given 4, and let x denote number of girls, and probability of girl and boy will be equal to 1 by 2. Number of girls, that is the probability of success, is 1 by 2, and probability of failure is also equal to 1 by 2, that is the probability of a boy. Okay, so now number 1. So using the binomial distribution, we have to find the probability of 2 boys and 2 girls. That is, if we are going to find out probability of x is equal to 2, this denote the probability of getting 2 girls, or we can say probability of 2 boys. So by the binomial distribution, it can be written as 4C2 1 by 2 raised to the power 2, then 1 by 2 raised to the power 2, or we can say 4C2 1 by 2 raised to the power 4. And this will be equal to, by calculation of scientific calculator, then it will be equal to 3 by 8. So out of 800 families, the frequency also we have to given. So we will find out 800 multiply by probability of x is equal to 2. That is 800 into 3 by 8. That is equal to 300. There are 300 such families in which we have 2 boys and 2 girls. This is the first point we find out. Second, at least one boy. Now, when we are going to find out probability of at least one boy, this is probability of at least one boy. Meaning is that probability of at most, the meaning is that probability of at most 3 girls. So when we have to find out probability of at least one boy, so this can be written as a probability of at most 3 girls. Why we write down this one as a probability of at most 3 girls? Because the probability of success, we assume number of girls. So we have to convert this statement in the form of number of girls. Then we can find out. So at most 3 girls, that is probability of x less than equal to 3. And this can be written as probability of x is equal to 0 plus probability of x is equal to 1, probability of x is equal to 2 plus probability of x is equal to 3. We will put up the values, that is, either we find out 0, 1, 2 or 3. 1 by 2 raised to the power 4 will be common in the calculation, and it will be 4C0 plus 4C1 plus 4C2 plus 4C3. 15 upon 16. And out of 800 families, so 800 into probability of x less than equal to 3. So this can be written as 800 into 15 upon 16, and this will be 750. So 750 such families in which we have at least one boy. The third one is probability of at most 2 girls. So at most 2 girls, we can write down probability of x less than equal to 2. This can be written as x is equal to 0 plus probability of x is equal to 1 plus probability of x is equal to 2. So we will take common 1 by 2 raised to the power 4, and within the bracket 4C0, 4C1 and 4C2. By scientific calculator, when you will calculate, then 11 by 16. And such number of families are 800 into probability of x less than equal to 2, that is 800 into 11 by 16, that is 550 such families. Fourth one is probability of children of both sex. Meaning is that both boys and girls should be there. From 1 we will subtract, that is all boys, that is the one case, and all 4 girls, that is the second case. 2 case we will minus from the total probability, that is probability of all boys, all are boys, and probability of all are girls. So that can be written as 1 minus. When we will write down probability of all are boys, then this is we write down as probability of x is equal to 0, because x denote the number of girls. And when we write down probability of all girls, then this can be written as probability of x is equal to 4. So finally we will put up both the values. X is equal to 0, so that is 4C0 1 by 2 raised to the power 4. And here we can write down 4C4 1 by 2 raised to the power 4. So that is 1 minus 1 by 2 raised to the power 4. 4C0, that is 1. 4C4 is also 1. And that will be equal to 1 minus 1 by 8, that is 7 by 8. Number of such families, that is 800 into Probability of 800 into this probability, that is 7 by 8. So this will be equal to 700. There are 700 families out of 800 in which we have children of both sexes. So these are some questions based on binomial distribution we done. Thanks to all of you, my dear students.